the time, but the date. But I thought Don's material is a critically important part of the success for either UAM, AAM, public service, corporate operation, etc. So to me, this will be a great meeting. I talked to Don and tried to absorb and understand as much as I can what he's doing, and I think it's amazing. I think it's critically valuable for the industry that what Don and team are doing. And therefore, I think having the session recorded will allow us, the rest of the member who could not attend in person online today, to have a chance to come back and go through it and probably get in touch with Don and ask more questions and get involved. So with that, I'm going to have, today's agenda, basically, Don Berchoff is our guest speaker, and the topic is micro-weather challenges and opportunities for UAS AAM operations. Don is the CEO of TruWeather Solutions, and he is a military veteran. And the TruWeather is bringing innovative weather science, technology, and micro-weather data service to the US and AAM industry. Don is an advisor to the Autonomous Institute and bring 40 years experience in weather, aviation, and logistics system to the industry. So I will pass on to Don shortly, but the next topic we're going to, if we have a few minutes at the end, we can cover a dynamic infrastructure development for eVTOL AAM public service missions, and we can have a little open discussion there. But I'd like to leave as much time for Don and the topic as we want to, so that we'll focus on the main topic here. So with that, I'm going to pass on to Don. Don, the floor is yours.
I guess, what screen are you seeing right now?
Let me close out if
we're seeing TVF Working Group's slide with your logo on it.
Oh, you are seeing that? Interesting.
Yep, we are, and it's full presentation.
Good. Well, that's good. So I'm ready to go then. So thanks, Johnny, for that great introduction. And thanks for you all that have joined today. We can make this more of a conversation if you like, since it's a small group. Please feel free to ask questions as we go along. And, basically, what I want to discuss today is something that, is pretty important to, to this industry. It's something that, did my slide change, by the way?
Yes, it did.
Good. Because I'm a little screwed up right now with my system also. So, but I'm good. I just want to make sure you can see what I see, what I'm talking to. Weather's always been a problem in aviation. I think, our weather data, granularity, our models, they've always, been uncertain. And, what's happened over the years is, we've lived with that system of uncertainty because of either the capabilities of the aircraft, larger aircraft, heavier aircraft, gas-powered aircraft, and the pilot on board the aircraft who, knows that when they're out and flying that there's a lot of undetectable things that could happen or things that are not forecasted that could happen. The pilot knows in a lot of cases that even though I got a forecast from the flight service office that when I go around a certain area of terrain or I go over a hill, I'm going to have some different weather than what I was briefed. And those heuristics are very deep, and that experience is very deep. The problem, in the future is, we're going to have lighter aircraft. They're going to be electric, so, you can't add really more fuel. They're going to have, be impacted, either weight, distance traveled, or time. And we're going to have a lot of micro hazards that are today unknowable in our current systems. Unknowable, meaning that even if you're a remote pilot working and flying an aircraft physically from, say, a distance location and flying BV loss, you cannot possibly know what the weather is in the area you're flying in because you're not in the cockpit. So this is going to be a little bit of a wake-up call as we start to scale out the system. And, folks are scheduling missions and running into things that are undetectable. And so, what I, really focused on here is this problem that I saw coming several years back. And the problem, isn't that you could be ultra conservative and say, I'm just not going to take any chance today or take any risk. But once you start getting those marginal weather conditions and, you have to fly because people are depending on it, the rules, change a little bit. So today, 30% of manned aviation that's canceled or delayed due to weather could have flown. And that's because of the uncertainty that's out there, and people become conservative. Now, that uncertainty and that conservation is usually associated with more impactful, in our mind, severe weather conditions, right? Icing and cloud, crosswinds, winds, big snowstorms that might be coming, things like that. But the problem is when you translate that into the drone air taxi industry, you're going to have a lot more less hazardous looking events that are going to actually add uncertainty. And that could be winds just being 10 knots stronger at 80 meters than what was planned, things of that nature. So what's going to happen is you're going to have, a reduction in what people think they're going to generate in revenue per asset, or you're going to have an impact to mission effectiveness rates compared to what you think you're going to have if you're in the government side and you're using drones to do those kinds of things. And you're also going to have people with customers that are going to be the drone delivery may not be reliable as we might think. Customer will look outside and say, I don't understand why my drone is canceled, but they don't see the winds at 80. It could be a clear day and those winds at 80 meters are blowing above the thresholds. So it's gonna get interesting. And I think, what we need to do is really think about weather differently around the aviation industry and really understand, what's going to be required from an infrastructure, a sensing infrastructure, a prediction capability to ensure that weather isn't as disruptive as it could be in the future. So what we're talking about is there's a data desert below 5,000 feet. That means that, satellites do a good job of getting measurements of temperature and moisture down to the boundary layer, we call it, planetary boundary layer. Which runs anywhere from, depending on where you are, from 3,000 to 6,000 feet above the ground. But once you get down below the boundary layer, satellite signals start to degrade in the atmosphere. And yes, we have microwave sensors that could see through to a large extent, but they're not as many of them. Usually they're on polar orbiting, so you don't have dwelling of information. And weather radar, is scattered. It gets beam blockage. It's not really everywhere. We have only 2 balloon launches a day at 77 locations in the United States that measure the temperature and moisture profile of the atmosphere going up. And then we have aircraft that land at airports that pick up some in those local areas. But in reality, our models that we use for our decision-making today, and which even our models that are analysis or 0 hour are all estimates. So anything above the ground is an estimate, even when you think it's real time, because we cannot know what we don't know. And so we run models, and what we're seeing is there's about a 50% error rate. I should say a 50% error rate is not uncommon in winds at 80 meters from what the model's demonstrating. I've seen days where the model had 14 knots of wind at 250 meters, and we had a Meteor drone up that was collecting 35 knots of wind. And I see that more. I see more of that than I see less of it. And that's just, again, the fact is that you can't pick up low-level circulations in these models from heating and cooling of the ground and transport of energy. So, we really don't know what we don't know. And it's amazing because it's so close to the ground. We think, how can we not know that? And only 3% of the country, you can measure the cloud height at airports. That's the only place we measure cloud height, is at airports. Everywhere else, when you see a cloud chart that's a forecast, it's all, micro models are not being picked up. The fog and the stratus that are in a valley or someplace like that. So, this is why we have to address the data shortfall, because with all these unknowns, and I haven't even talked about the urban areas yet, which there are no data and models available to actually know what those winds are doing in urban canyons in real time operationally. Yeah, there's research being done, lots of great research, but nothing's operational. And that's because it's expensive and there hasn't been a business model for it. So just to give you an idea of what this gap looks like, this is the truth. It's exactly the way it looks. And I even put LiDARs in here that don't exist in some places. The X-band is a radar. And so we got to start thinking about how to fill that gap, because we're not going to have the human pilot anymore as the last line of defense on the aircraft. So what we've been working on in TruWeather is this concept from the ground up, which isn't really my concept. If you look at that link, Observing Weather and Climate from the Ground Up, this was a National Academy study that came out in 2009. I was at the first meeting in 2008 in Woods Hole. I was the science and technology director. I had just got on board at the Weather Service, and I was invited to this meeting. And what this study, which, by the way, this is the book right here. I keep this on my desk because this is the Bible for me. This is like, everything I do is not my idea, right? It's everything that came from other smart people. And this is basically saying you need to have a profiler network across the country that can look up and see winds and temperatures and moisture up to about 5,000 feet above the ground at 400 locations in order to really improve the micro weather forecasts and get better resolution and better forecasting. And so what we've done in TruWeather is said, well, let's try to fill gaps where we can and get some instruments out. And with our partners and companies we're working with, what we've done is said, okay, if you put out this IntelSense sensor in the middle, which is a tactical sensor, it does about as well as an ASOS in most areas. It has a ceiling height indicator, visibility sensor. It's on solar. It can go to an iridium chip. And that basically can give you a ceiling and height measurement in places where you don't have one and where you're worried about fog and stratus, that when you're flying a BVLOS site, beyond visual line, if you want to stay within the rules, which are 500 feet below a cloud deck, and you want to stay in the rules of 3-mile visibility, that will help you, validate. And those are tactical and you can move them around. And then there's other sensors here, such as wind LiDAR on the right, which is a single beam wind LiDAR that we're about ready to hopefully get into North Carolina at an airport for drone operations. We could see the winds up to 800 feet with that. We have the anemometer anemometer, which is on top of this pole. It's a really good sonic anemometer. You get up on a tower, you can really collect winds above the tree level. In North Carolina, I call it the treetop inversion, because you get out from the pines on the surface and the winds will just increase rapidly above. You almost get a low-level jet above that. And then the wind LiDAR on the left is a scanning wind LiDAR. This is being deployed down in Hampton, Virginia by NASA funded. And then we have the Meteor drone, which is going to be deployed up in North Dakota. This is going to be the first one in North America that's going to go up and collect atmospheric profiles on a regular basis. So these are the types of instruments that we're bringing out, and we can integrate these into our APIs and make this available through our products today. And it's just the beginning of trying to figure out how to close some of these gaps. But that's just us. We really need something broader. We need an infrastructure that is going to be broader. Most businesses today don't hedge against their weather risks, and a lot of that has to do with the fact that they just accept that weather is what it is, and they'll push ahead with a plan even if they know the forecast is marginal. They'll spend a lot of money trying to fly or get to a location and then not be able to fly and pay people for that. And what we really know is that the U.S. economy, $634 billion is the cost of weather on the U.S. economy. And that's all due to a lack of productivity caused by uncertain weather or weather that occurs. we know that about 30 to 40% of that's avoidable if you choose to develop some systems that take advantage of weather data in a way that and you build a framework around how to use the more certain data and things like that. But the drone delivery market, is really projected to grow quite a bit. And, the challenge is that we're already working with some drone companies, and they know this already, is that the current weather systems and automation, the weather apps, or even though the weather company data they're using it's not resolute enough to make an automated no-go decision, because it winds up costing them to be grounded more than they need to be. And that costs money. So, and these are the weather impacts that are very difficult to measure today. Yeah, somebody will give you a forecast model and say, oh, this is where the ceiling are going to be, and this is where the freezing drizzle will be, but it doesn't mean it's accurate. Every time you look at a weather picture and a visualization, it's really probably not, it's not going to be accurate in every location. It just looks good. And so we got to, backfill this and make sure we know what we're getting when pilots are using data where they don't have that experience of being out in the weather. And then we got to worry about the urban canyons and the eVTOLs and ride comfort and, Ventura wind effects and, pop-up thunderstorms in Florida are going to be very tough because they pop up fast. If you have an air taxi that is picking, saying, hey, you come out and to this vertiport and we'll bring you to the airport. And, they don't anticipate thunderstorms. And then the family gets there and they know that they have a point of no return because they can't get to the airport fast enough by vehicle anymore because they're in Miami or someplace where there's a lot of traffic. This is really going to be impactful. And that's kind of what we're focusing on here. I talked a little bit about air taxis, and again, there's going to be a lot of air taxis starting to fly probably in a couple of years that'll be manned first or crewed, and then move towards automation later. But the point is, even if you have a pilot on the aircraft, the question is the predictability and reliability of the short range predictions. And then we're talking about also these middle mile drones, which will be doing regional heavy cargo delivery between regional airport. Most of these are going to fly like 1,000 to 5,000 feet, maybe 6,000. That's right in the weather zone. And clouds that have icing, there's no way of knowing if a cloud really has icing in unless you fly in it today, or you go by the forecast. And we're working up in North Dakota with some companies up there and the government. And basically, if they have trace icing in the forecast, they don't fly. And we know they're being grounded unnecessarily because we know our icing forecasts aren't very good all the time because we don't have a lot of data. It's a science problem. So how do you know? Are you going to shut down corridors because you think there's icing in a cloud, or are you going to figure out if it's really up there or not? And those are the kind of solutions that we're bringing into the area. Any questions on that so far? I mean, anyone have any, that's kind of the opening discussion here. Okay. Nobody argues. Everyone believes me when I say this. Okay.
I think we're still trying to absorb all that information, processing as we go. So, yeah, it's a lot of good point. When you're not bringing it up, people were not spending as much thinking about real world operation opportunity and challenges. So we have Eric raise a hand. Eric, you want to go ahead?
Hey, good afternoon, Don. Thanks for doing this. My question is related to heavy snow in addition to icing. I guess curious what impacts, lake effect snow news that was in the recent weekend is coming to mind. Just curious what your thoughts are.
Well, lake effect snow showers, again, I mean, obviously, if you have an event that's very clear and it's not uncertain, like the lake effect snow event was very clear, it wasn't uncertain. I mean, there's not much you can do about that, right? You're just not going to fly. But the challenge becomes when you have lake effect snow bands that set up and you don't know where they're going to set up, right? I mean, anyone who knows anything about the lake effect snow knows that the wind flow and the direction is very important. And if it moves just 5 degrees, which is very, it's within our range of missing the forecast is 5 degrees of wind on the direction, you could be off 15 miles on that lake effect snow band, right? So if you're trying to, figure out what routes to take, or you're worrying about, vertiports, taking people to airports, that's going to get squirrely, definitely. Now, obviously, you can't fly in heavy snow, or you shouldn't. Maybe you can. I always have people tell me, "Oh, Don, we're going to engineer everything. We have all-weather aircraft." Unfortunately, I've been involved in aviation business in the military since 1984, and they've been telling me that since the day I came in the military. And I always ask them, "Where's that all-weather aircraft?" Because you could build anything to fly, like an A-10. Biggest military vehicle. It's a tank, right? It's heavy, right? Heavy weight. Can't carry as much stuff. You need more power. There's a whole bunch of engineering challenges. So no, that's going to be a problem. Like lake effect snow band. The start and ending time of snow, right? Where is it going to start? When's it going to end? How heavy is it going to be? Can I fly through a light snow, but is it going to wind up being heavier? Is it convective snow? All those questions are really hard to answer, right? I mean, when it gets down to the micro scale, it's going to be a challenge, So, and so what we need to do is not only improve our measurements, but we have to improve our modeling once we get those measurements. So if we start improving the collection of data in the vertical, those go into models that with that data, we can actually do a better job of getting those predictions a little bit more micro scale and pinpoint. So Eric, I don't know if that answered your question.
Yeah, it does. Thank you so much.
So let's talk about, a couple of real world cases. So, I know that Johnny said to me, hey, let's talk about, emergency management and disaster response. So I'll focus a little bit on the public sector here. And of course, I have lots of experience in the public sector. I ran an Air Force base in Central Asia, and I was actually the Emergency Operations Center director. So I had to deal with responding to disasters. We actually had 12 inches of snow in 5 hours at Manas Air Base when I ran that base. And I was a weather guy and I was in charge of the base. So you can imagine I had to keep the aircraft flying because at Manas, we were in Kyrgyzstan. Our tankers would take off out of Kyrgyzstan and go down to Afghanistan and refuel all the fighters and A-10s that were supporting the ground guys to make sure we can take out the bad guys that were hurting them. So if we don't get our tankers up, we don't get the fighters up, they don't have the cap. So I took very personal interest in this. And because of the fact that I was a meteorologist and because of the fact that I owned the equipment and I was able to tell everybody what to do, we had our first snow of the year and we had 12 inches of snow in 5 hours, and we were able to keep airplanes flying. And that was only because of this integration of understanding the weather, understanding the impacts, understanding what it was going to take, getting everybody aligned, and we were able to pull that off. So again, a lot of this 634 billion, some of it has nothing to do with the lack of weather data. It has to do with the way people make decisions in their personal biases about weather and whether they like weather people or not, or, there's a lot of human factors in people making decisions around weather that go beyond just the data, which is why I think when we move to machine, it's going to be better actually. But the data is not always going to be perfect. So how do you then override that with a human when you need to? And those are the kind of challenges we're working on, TruWeather, figure that out. But drones are a force multiplier, and as people start investing in them, especially in the public sector, they're going to start cutting other positions. There's no free lunch, and so if you replace, if something's easier to do, like go out and do a traffic reconstruction, accident reconstruction, and you sell them on the fact that get me 5 drones for that, they're going to say, well, all right, so how many people are you saving by doing this? And they're going to have to turn in 3 positions or something, and then drones become the main thrust at that point. And then you got to make sure that you have a good plan to mitigate the weather and make sure you can still cover that mission. So you need predictability. to know that, hey, tomorrow we're not gonna be able to fly this drone, so we're gonna need to pull people off the desks to go out and do traffic accident reconstruction if we need it, because we won't have those people maybe full time. And that's just an example of why they're a force multiplier, because they could do things faster, cheaper, better, but the weather is going to be an impact. And once you have that impact, what's your backup plan? And so that's our job, TruWeather, is to say, all right, here are your threats. So when you're going to go out and use these, you got to have a backup plan if the weather is not participating, contributing properly. But also, how are you going to know with certainty what that weather's doing, so you can keep them flying as long as possible if you're doing a BV loss mission? Now, visual line of sight's different. I'm talking about beyond visual line of sight. So, you know, drones contribute a lot to the public mission today. I mean, they're using them for security around prisons. Custom Border Protection is using drones to go down and surveil the border, surveil looking for drugs, people trying to cross the border with drugs, looking at where fires are breaking out, conducting intelligence, law enforcement. You know, they're being heavily used in the public sector mission. And so the more you become dependent on them, the more weather sensitive a mission becomes that wasn't weather sensitive before. Because before, if you were sending out somebody to just go out and do rides around the perimeter to check to see if, you know, if everything's under control, yeah, the weather can impact you, but it's not going to impact you as much as trying to get a small instrument up in the air. And a funny story is, when I ran the base in Central Asia, I had security. It was my responsibility of the perimeter. And I used to go into the special operations, security operations center on nights when it was foggy on purpose, because they were using cameras to do the surveillance. And I knew they couldn't see anything, but yet I knew they didn't change their tactics, techniques, and procedures to make sure that they covered for that gap. So I'd go in and say, hey, how's everything look tonight? And they go, oh, it's great. Everything's great. And I go, well, how do you know? You can't see anything, right? So these are, you know, that's a weather impact on an operation that you have to have mitigation. You know, this is an example of them using drones to do the accident reconstruction. Really good stuff. I mean, amazing. They tell me that these could be like a 4-hour job. They can do it in like 30 minutes. They can open up the roads, get things going. Really great use of drones. But what's interesting is, even with a VLOS mission, you can't see the winds aloft, right? Even if, so they say if you're visual line of sight, well, how could you see the winds aloft? You can't see wind. If anybody here could see wind, let me know. And what we've seen is there's been a lot of accidents, even for VLOS, because of wind shear aloft. This was a case that happened up in the New Air test range several years ago. And they flew several drone missions in the morning. They were using their ASOS right there. They were on Griffiths Air Force Base. They were using their handheld anemometer, Kestrel, and they were saying, oh, everything's good. What they didn't know is the winds were blowing like 40 knots at 2,000 feet that morning, and there was an inversion. And we knew it. They didn't want our support that day because they said it was VLOS, so they didn't need us because we support them every day. And what happened was that inversion started coming down, and they flew 3 missions up to 350 feet, no problem. Winds were calm, boom, boom. Then on the 4th one, the inversion crashed down below 400 feet. They didn't know it. Their aircraft hit that inversion and they lost control and it crashed. And there's more of that going on than people like to admit. You know, there's not really a good reporting mechanism for all that right now. And, you know, people don't want to, you know, necessarily tell everybody about the problems they're having because, you know, it's just not a good story. So when we talk about disaster response and recovery, we're always thinking about, you know, how do we anticipate, right? And so that with the micro weather, you know, when am I going to be able to get my drones up? You know, where should I place them pre-positioned? How will I know when I can launch them safely? Where am I going to send them? You know, all these things you should be thinking about ahead of time. And weather prediction is a key part of that in the preparation, response, and recovery. So I always told people, you know, when you're thinking about an emergency response, you need to think about what assets you're going to need, where you're going to put them ahead of time, and when are they going to go, right? So all these questions in the fog of war and in a chaotic weather condition adds more fog of war. You really got to think these through ahead of time. And so, we always tell people, you can always talk to a weather person and say, where should I pre-position the drone so I know they're not going to get destroyed during the storm, but they're close by, right? This is really an important question, right? What assets are you going to use? And then when are the wind conditions going to be aloft, and when are the weather conditions? Are they going to be acceptable to fly drones? Or are you going to have to use helicopters to do your search and rescue? I know in North Carolina, I've had many conversations with them about how on the Eastern Shore, it's really difficult to know after a storm when they can go fly over there, because there's really no weather equipment, and it's a guess. When you're doing search and rescue, you got to think about things like absolute humidity and how they impact IR sensors. You could fly the wrong time of day looking for bodies under rubble, and you might miss them because of the crossover thermal effects. You might get enough heating of the day, but not so much from the sun that it's blocking the thermal signature of the person underneath the rubble. And you really got to understand that, or else you can actually leave people buried. And then in urban areas, you got to worry about things that you don't really have to worry about in the rural areas, right? Or in the suburban areas. You got to worry about these turbulent eddies, the Ventura effects, the rapid changes in wind speed and direction. If you've ever been in a big city and you know that you're walking down the street, you don't get a lot of wind, and then you hit that corner and you get knocked on, you get pushed, right? Drones need to know where that is. I mean, I talk to folks in New York City all the time about the challenges of using drones in the city. You also got to worry about like coastal cities and urban areas where there's microclimates. Think about San Francisco. They have the marine layer and the fog. So if you're flying BVLOS, where is it? It's not always known where it is, very simply, right? It's subgrid to our models. And then you got the heat island effect. So, if you're flying a drone off of a building and it has a black roof, and your temperature, might be 85, 90 degrees, but that sun hitting that roof makes that temperature more like 120, which happened during TCL 4 out in Reno. Your whole density altitude, everything gets affected by that. So these are things you got to think about. And in the urban canyons, I mean, this is a classic example of what things could look like, and you wouldn't even have a clue that that's what you're going to be running into, some of those red areas that are not intuitive, right? Okay, so we're working on some of this stuff. TruWeather is down in Hampton. We've got 3 NASA SBIRs that are funding us to put in 2 scanning wind LiDARs. This is an example of what we're hoping to accomplish by seeing these winds at stratified layers and watching how buildings impact the winds. And, if you're talking about air taxis, trying to keep people away from those orange areas as they're ingressing and exgressing out. We've talked a lot. I've been very involved in the AAM community. I helped write the weather ConOps piece of the Advanced Air Mobility ConOps. We need to be thinking about how we're going to identify, these winds in an urban area, but do it in a way that's affordable. And so that's what we'll be testing, down there. We're also working on the weather standards to match this. So ASTM F38 weather standard, I'm leading that group. I started about 2.5 years ago. It's a lot of work. I don't get paid for it. But what we're doing is basically we're moving in a direction where we go from having to certify weather instruments, which is what happens today at airports with the ASOSs. They're very expensive, to data performance standard. That way, if we can use IoT data sets for weather, basically, as long as you know where it came from, you can quantify how good the data is. You publish that in a standard, and you have a means of checking that and then making it discoverable with metadata to the end user and the UTM, the Air System Traffic Management Provider. So everybody knows what that error rate is on that particular data set, so they can incorporate that into their risk-based decisions. So we're working that right now, and we have a draft that's about 90% done. I had to rewrite the quality control component of it this weekend, and I met with the FAA, and they want to have more time. But we're going to be meeting up in Pennsylvania on the 8th of December or 7th of December, 6th of December, in that period to do a review of where we are. And the goal is to, get this standard out to the whole world. I just was up at an ICAO conference up in Montreal and briefed on this. And a lot of the countries were excited because they know that the current MET systems aren't going to work and the rules are so tight that you can't use other data sets. We need to have an ability to use and crowdsource data so we can close these gaps, drive down the cost of weather sensors, and also increase the quality and the amount of data. And so that's what we're working on. So the takeaway here is we're going to need weather infrastructure, and the longer we wait to reach that recognition, the more expensive it becomes later. So as we're building out our smart cities and adding infrastructure for advanced air mobility, we need to have the weather piece baked in. Otherwise, as my friend Joey Rio says, we'll be trying to sprinkle it in later, and it'll be a lot more expensive and it won't be comprehensive enough. And we need to think about, these ConOpses around cargo and middle mile drone delivery. We can put, we need sensors with data aloft. We don't need more surface data necessarily, except in the cities where we need the wind data. But up, aloft is where I'm most concerned about. What's those winds doing for drone delivery, for small drones? What are those winds doing? What's that icing look like in the cloud for cargo and middle drone delivery along corridors? There are solutions, to detect icing by flying drones into them and scouting. And we're working on another concept called a Weather Scout drone that will have a payload on it that can carry a radiometer. And with a radiometer, you can actually, it has like a little camera in it that looks, picks up the spectrum around microwave spectrum, and passively can pick up temperature, brightness temperature off of water droplets. And you can tell if something's a super cool water droplet without flying in it or not. And these are things we're working on. But, again, this idea here is we do need to increase our infrastructure. Otherwise, our costs are going to go up to the industry. And it's really, to me, it's about a 10-to-1 return on investment. If you do a really well-conceived layout of infrastructure, your customers will save, 10 times more than what they'll pay for their weather data. And I know this because I was in the military and I did many studies. Some of them have been published about this. And also, when I was up in, I went to an eVTOL conference up in New York several weeks ago, and Archer was briefing on their aircraft, and they talked about they're going to fly 8 missions a day per aircraft, 365 days a year, and they mentioned they'll generate $14 million in revenue per year per aircraft. And I'm just sitting there thinking, did you include weather as in there? Where's your weather tax? So I had to speak later in the day, and I went up and basically said, look, you're going to have a weather tax in New York City of 20%. I mean, there's just no way around it. And because you have weather in New York City. And I said that tax is going to drive your revenue from 14 million down to 10.3 million. I hope you told your investors that. And we could get you back 30% of that weather tax if you just like in the IRS, if you have an accountant, they can help you figure out how to save that money. And I basically laid the case out that with the right weather infrastructure and the right methodologies and decision systems, you can recover 800,000 of that at a cost of about 80,000 a year. So people think about weather, they think, I don't want to pay for it. Well, you are paying for it, and they've got to change the way they think about it. It's an ROI play now, rather than just a safety play. Safety is important. Of course, if we get more data, it's going to be more safe. So I feel pretty comfortable about that. But it's also an ROI play for the industry. And they've got to start viewing it as this data is part of their ecosystem, and it's going to get them better service, more revenue per asset, and it's going to give better customer service, right? And TruWeather is actually partnering with a cell phone a cell tower company, and we're starting to move into the next realm of how do we get some profilers up, get some these scanning wind lidars out in other places, and what's the business case for it, and how do we, it's like rolling out the cell phone network. Let's put them where the action is. Let's recover the cost. Let's amortize the cost. The more flights, the lower the cost, right? The more flights, the better the capabilities in that area. And this has to include local scale modeling, because the urban area has to be modeled, and we're working on that right now. There's nothing that exists operationally today for that anywhere. And we also got to supplement this with humans, because the weather is always going to be uncertain until we get a fully knowable understanding what the atmosphere is doing. You're always going to have uncertainty. And the meteorologist is the heuristics that knows the strengths and weaknesses of the models, and they need to be there for the big decisions, or when the models are the forecasts are just going off the rails, and people are trying to make decisions about when do I start flying again, when do I stop flying. Every hour is money, right? So we want to really help them to nail that. So in the end, there is a real opportunity here to think about weather differently, understand, what these impacts are, understand that there's a real business case for it, and recognize that there's solutions. You don't have to accept what you're getting because of the way it's been. I make an argument that the weather industry is underperforming compared to what our science and technology has on the shelf. And there's a lot of reasons for that. I don't want to get into it here. If you want to have a conversation about that, that's another book we can talk about. But it's structural, not technical and scientific. And so that's what we're trying to do, is trying to just get people thinking differently about this, working with NASA, the FAA, and companies to make this happen. So that's what I had today, Johnny.
Hey, great. Great stuff. A lot of information here. Hey, folks, anybody has any questions or comments for Don?
I do. This is Nicholas Zark with the Vertical Flight Society, and one of you actually raised so many great points. It'd be hard to ask all the questions that we have. But one of the things that I've been noticing is, you're right, not a lot of companies take into consideration whether there's a preconceived notion about weather. And it's true, you turn on the TV and 40% of the time it's wrong, right? But I was thinking about especially some of the companies that you've mentioned, but things like San Francisco, where you have micro weather, where you have changing weathers and everything. Do you think that these UAM/eVTOL companies are changing? Are they starting to talk to you? Because so far it hasn't been part of the discussion, but I think now, and we've had you guys, by the way, at Dayton. Thank you. That was so good to finally get that perspective. Do you think those companies are finally changing, and are they taking it not seriously? That's not the great word, but are you engaging in more conversations with them?
Yeah, so that's a really great question, and I see that Jim may be listening in or from somewhere. But yes, the answer is yes. What I've learned, and this is purely my observations and facts. This is not anything, this is not emotional or opinionated or personal. The challenge we've had is that once you start getting the CFOs involved and understanding this, once you start getting the business managers involved to understand this, and you get away from the pilots giving their opinions about this, that's when they start realizing this is a business problem. So, pilots are great. I mean, they're amazing, and they'll tell you that they've gotten through a lot of tough weather, and they can get through tough weather, and the services they have are fine right now. But they don't understand, fully where we're going, and automated weather, machine to machine, and these gaps. And so when you start really introducing it as a business problem, and you bring that forward, now they start paying it more attention, because these folks care about the bottom line. And I'm seeing more and more of that. In fact, I can't talk about some of what we're doing, but yes, our phone is starting to ring a lot more. I mean, I've been on this kick for 4 years, as some of you may know, and people were tired of hearing about it, but now it's becoming vogue. And what we have to do as an industry is embrace that this is a problem. It's another one of those inconvenient truths, right? And if we embrace it and we plan for it and we recognize it's not a cost center, it's actually going to generate revenue for you to have this data. I think, we have to flip that whole thinking, Nick. And by the way, I was going to put in another abstract for your shows next year, but I couldn't write another abstract. But if you want to, I'll be more than happy to come and give this presentation or any other presentation at the next VFS. We are a member of the VFS, and I love what you guys are doing. And if we can tell this story better and get the right people in the room, I think that would be really good. Yeah.
Perfect answer. Yeah, but that's why we're here for. So we'll always help, no matter what.
Yep. Great question.
Hey, Don, I have a quick question. Actually, I have many questions, so we probably won't have time to go through it all. But just one of the things you talk about, you mentioned that maybe we, from where we stand today, maybe we need more of ground-based instrumentation, but more aloft data collections and so on. Can you elaborate on that? Are we thinking about having, let's say, an urban center with a lot of UAM in the future operational? Are we thinking about getting a fleet of weather drones up there flying around? Are we talking about the emergency situation that we have some stationary sensor deployed when we are, post-disaster recovery, whatever, what are you thinking? What are you talking about?
Yeah, that's good. So first of all, I don't want to say we don't need surface weather stations. I don't want to say that. But what I want to say is if you ask me to prioritize, I'll tell you the impacts of not having data aloft far outweigh the impacts of not having more surface data. Now, that being said, in urban areas, we do need more wind data at all levels of the urban environment. So when I think about a vertiport, wind socks aren't going to cut it. Crack me up. In one of our standards, they're like, oh, we'll just wind socks. No, helicopter pilots will tell you that when they're going into an urban area and they're trying to get to a heliport and the winds are blowing, it scares the living daylights out of them. So if you try to run a high velocity vertiport operation where you're turning 30 aircraft an hour with 2 FOTSs, whatever, you're going to need much better data. So you're going to need 3-dimensional data in that area. And I have ideas about how to do that. So the urban area is one thing. I think outside the urban area, and if you're talking about, yes, I think that the sensing strategy encompasses several different diverse sensing types, right? So when you talk about mobile, you're going to have like our weather instrumented drone that just is stationary but goes straight up and down, takes a profile. That's important because the models handle that better. Then you'll have the weather scout that can go out and fly and go look for icing and turbulence and other things. And then you have every drone could be a sensor. So even if we decide not to put an anemometer or a weather sensor on a drone, we could still back out the telemetry and flight control data and figure that out. Now we have to figure out how good that is, right? So I see that. And then I see, like, when you're talking about a mobile capability, yes, I think you can deploy a mobile sensing package into an area that could be associated with other deployments of things like mobile cell towers. And we've had these conversations with AT&T and FirstNet. It's all doable. We built a back end system where if you said, all right, we're going to have 10 of these sensors deployed whenever there's a disaster, and we're going to get them out with the mobile cell towers, or we're going to get them out with some kind of detect and avoid radars that they bring out for drones to operate. We could get that. You turn them on, they'll turn into our API feed and it's out. So yes, I think we're talking about a lot of different things, Johnny, right? But I think what's going to underpin all of it is the standard and the data quality and having a means by which we can validate or quantify how good that data is. Because the worst thing that can happen is people start throwing data in willy-nilly into the pot, right? Like somebody thinks they got a really cool sensor on their drone, a weather sensor, but what people don't understand, it's very complex to get weather data off of a drone. If the sensor is in the backwash, if it's in the wrong area, if it's near the heat, battery heat, there's so many problems. And so we got to hold the line on that. But other than that, yeah, we're talking about a whole myriad of opportunities to do different things.
Understand. I guess that's a collection of. I guess we can't raise the child. Well, we need to raise the child by the village. I guess we're talking about a suite of complementary solutions, putting information, putting the sensor together, and have a methodology to let the end user easy to use them.
Right.
And understand what the accuracy or what confidence level, how much
Exactly.
to trust what data. Sounds like that's critically important.
Yes. And we're talking to NASA about that and FAA about how to do that. And there are techniques, that weather is used for many years to use nearest neighbor concepts to understand how sensors are performing and things of that nature. But, it's not simple. I'm not going to say it's simple, but it's solvable, right?
Okay. Understand. Sounds good. Hey,
Yeah.
Anybody else has any questions for Don? We're running a little bit short on time now, so if you want to ask questions or tell what, I know this is a deep subject that we can carry on the discussion for a long time, and we probably have additional ideas. So feel free. I'm sure Don don't mind. Welcome any comments or questions and dialogue discussions. And I think Don said it right, that we need to expand and get the right audience, get the right people involved, engaged, and we need to address this together sooner than later. That's much more cost effective. I think that's one language that a lot of people understand in the business. So
it's not going to go away. It's
exactly. The more we want to provide reliable, predictable services, regardless whether it's for commercial, for the response, or whatever, this is critical element. Definitely, we don't want to try to send out the rescue eVTOL for medical transport and just realize that we couldn't get there, and not good situation. If we knew we have a challenging condition, we could have sent a ground vehicle out. Not perfect, but better than not having the solution. But we need to know. We need to know and be able to judge on a fairly accurate basis. Now, Don, hey, we thank you so much, and I'm going to talk to you more.
Oh no, this conversation is not over. In fact, I hope you'll send the recording out, and I'll get it out myself to share with people. But anyone can write to me and talk to me about this anytime. This is my favorite topic in the world right now. I'm on a mission because we have the technology. I don't know if you remember the Bionic Man. Johnny,
I was thinking when you said that, the $6 million man, right?
$6 million man. We have the technology, we have the science. We just got to you just got to put together, and we got to make sure people realize it isn't going to be a problem. Sometimes it takes people to get in the eye into the hurricane before they realize, oh, this is a bad place to be. We don't want that, right? We know this is coming. It's not going to be a disaster, but it's just going to cost money, right? It's just going to get frustrating when it's going to add more chaos to something that's already chaotic, and it's going to be the weakest link in your whole chain, because everything else is, we're going to have perfect this and perfect communications and perfect remote ID. And then we're going to have this thing in weather, which we're using a 1990s or 1980s technology to try to support a 21st century, autonomous networked system. It's just, to me, it's, it's just a little crazy. That's all. But anyway,
I hear you. I'm with you.
that was my passion plea there. So
perfect.
Thank you, Johnny. Thank you, everyone.
Hey, thank you so much. We'll continue the dialogue and discussions. With that, I think we just ran out of time. So we're going to move the dynamic infrastructure development, which, whether it is part of that, to next month's December meeting topic. And we're going to also cover backward review, but more look ahead, what else we want to focus on in the working group. So again, thanks everyone. And we'll have the recording available for whoever was not able to join on real time. I think this is a critically important topic. Don, I appreciate that you're taking a lead and driving, and the STM effort is so much, it's critically important as well. So I thank you for the industry, and hey, everybody, have a great Thanksgiving.
You too, Johnny. Thank you, and thanks everyone.
Thank you.
Thank you, everyone.
Thank you.
Hey, bye-bye.